Can you hear me, Saba? Can you hear me, Saba? Good. Okay. Can you hear me, Saba? Okay, hello everybody. My name's Andy Smith, and tonight I'm going to do a probably it's going to say short, but it won't be that short. Probably about 15 minutes to an hour around Oxbridge maths and computer science, physics and engineering admissions tests, because these are very specific to these tests. So who am I? I am Andy Smith. I'm an Oxford maths graduate from quite a few years ago now, but I went through this journey myself back in the day. Since then, I worked in industry and government, but then when I took a career break to have children, I retrained as a maths teacher, and I've worked in independent schools, mainly in the Midlands, for over 10 years. And then a couple of years ago, we moved back up to the Lake District, where my husband and I both come from. And now I'm a private tutor living up there. So I've had a good 10, 15 years working with students and helping quite a lot of them go on this journey through into Oxford and Cambridge. Just in the last couple of years, I've had pupils go to, I've had computer science at Cambridge this year. I've had help them with maths at Cambridge this year, computer science at Imperial College. I've actually got somebody onto the maths, got an offer for maths and statistics from Oxford, which I was absolutely delighted by, because there's only 8 places in a year. So to get an offer on that is quite something. So I've worked with a lot of different pupils going through this journey together. So first of all, thank you very much to the Oxbridge and University Journey Facebook group for allowing me to do this. Very, very good group. I've had lots of, I've learnt lots of things from people on the group, and it's a very nice, friendly group. So thank you very much to the people on there. Okay, so what we're going to talk about today. First of all, I'm going to look at the additional tests required for maths, computer science, physics and engineering. We're going to look at which test for which university, because there are quite a lot of different tests with different things required for different universities. When do they take place, because that varies. What is the content required? So what actual maths and physics do they need to know in order to do them? But also what the format of the test is and what the skills are that are needed for each, as they do differ. So I'm going to start by looking at the maths and computer science together. And then once we finish that, I'll look at physics and engineering together. So looking at maths and computer science requirements. So before we actually look at the additional ones, I just want to quickly talk a little bit about the A levels and the IB requirements. So if you're doing A level exams, then if you want to study maths and computer science at any university, regardless of whether it's Oxford or Cambridge or any of the universities in the UK, obviously it's recommended that you study maths and further maths at A level, but only if further maths is available. So every school offering A levels will offer maths, but they don't all offer further maths. And most unis accept that not everybody is able to do further maths because it's not actually available. So it is okay if that's the case. You can say that you can't do it. However, they do usually want a confirmation from the school that it wasn't an option. So if you just chose not to do it, then they perhaps won't accept that. But if it isn't an option, then that's fine. IB maths. Now this is slightly complicated. It's IB, the International Baccalaureate, You do 6 subjects, of which maths is compulsory. So everybody doing IB will do maths at one level or another. It's split into the standard and the higher level. And obviously any people looking to do maths or computer science should be studying at higher level. But just to complicate things further, even at the higher level, it's split into 2 different streams. So applications and interpretations called AI and analysis and approaches called AA. They both are done at the higher level. They will both get you the same IB qualification at the end. However, some of the universities, Cambridge, Warwick, Edinburgh, a few others, you would have to check every single one, will only accept the AA course if you're looking to do a course where higher level maths is required. So maths, computer science, some of the engineering courses, etc. If you're doing the AI course in IB, it's not even accepted as the qualification by these universities. So that is something to be aware of, and please do check these things out before you make decisions. So now looking at the additional tests, which is what this is all about. So if we're studying maths with philosophy, maths with computer science, etc., or any of the computer science courses at Oxford, Cambridge, Imperial College, or Warwick, they require pupils to sit additional exams on top of their A levels or their international baccalaureate. What's less well known is that a number of other universities also like pupils to sit some of these exams, and they will often offer a grade reduction on A levels if you do so. So they might knock a grade or 2 off the requirement at A level if you've done well in these exams. So this is a list of the ones currently I could find, but I'm sure there are more than this. So it's always worth checking if you're looking at different university courses to see whether or not doing some of these exams might be taken into account as part of an offer. So the 3 main maths exams are the mathematics admissions test called the MAT, 6-term extension papers, 2 and 3, which are called the STEP, and the test of mathematics for university admission, or the Cambridge test of mathematics for uni admission, CTMUA. There's also another computer science specific test called the Computer Science Aptitude test, the CSAT. It's a little bit of a murky world, that one. Not a lot of people know about that. So first of all, talk about the mathematics admission test, the MAT. So this is a requirement by Oxford. So if you want to do a maths course at Oxford, you have to do this. It's also a requirement from Imperial College, unless you decided to look at Imperial too late and this has already happened, in which case there are other options, but it is their preferred test for you to do. And it's also one of the options that Warwick will accept. So Warwick have 3 different things that they will accept. So I said if it was too late, you'd already got past it. That's because it's set in November. So if you have somebody currently in year 12, then they would be sitting it in the coming November in order to then that be put as part of the interviewing process. So closing date for entries is usually, I think it's the 15th of October this year, middle of October. This test itself has a high level of problem solving skill. So you need to have, in order to do well in it, you have to have an excellent understanding of the underlying maths needed with problem solving, and then you have problem solving skills overlaid on top of those. It is hard. It is a hard test. So in 2019, the average scores amongst all applicants was 44.9%. Successful applicants, so they're people that were shortlisted and then got all the way through and actually ended up going to Oxford or Imperial, it was 69%. So bearing in mind, these are going to be the best mathematicians in their schools that are doing this. And they will be used to getting 90% plus in maths exams. So this is a bit of a shock. And they're not used to this. So they will find it more, they often find actually that side of just suddenly not being able to do a question straight away is often the hardest part. I'm now going to look at the TMUA and CTMUA together as well for a reason. So they are basically the same test as each other. The TMUA itself is not specifically required actually by any university, but it's one of the options that Warwick looks at. And the results from it are taken into account by the other universities that we talked about. The CTMUA is compulsory for computer science applications to Cambridge. So that is compulsory. It's basically the same test. And again, it's sat in November. So this is why if you've taken this test or you've taken the MAT, other universities can look at those results, and that's why you might then get a reduced offer on A-levels. The maths questions in it can actually be a little bit more straightforward than the MAT, but they have a lot more logic-based questions. I think as much as anything, because it's the CTMUA, which is actually what the test is aimed at computer science applicants. So I'll put these together because the actual content required of them is very similar. So if we look at the MAT and the CTMUA and look at what is the maths you actually need to know to do it, for both of them, it's broadly based around the first year of the A-level maths course. So further maths knowledge isn't required. So it's just the first year of single maths, with a few exceptions added on. So sequences and series, which is usually taught in year 13, is included. There are some elements of the calculus, so differentiation and integration, that usually go into year 13. They're also included. Something called combinations and permutations, which used to be on the old A-level, but isn't on the new A-level, is included in this. So that's something different that people will have to, the pupils will have to make sure that they know about them. And these logic-based questions, lots of those in the CTMUA, but MAT has them as well. So that's not formally taught at A-level, so it takes some practice. Now, a big item on this is that for both of these tests, they are non-calculator and no formula books are given. So a level of mental maths and formula and value recall is required that A-level just does not need. For anybody in particular that did the international GCSE, which was all calculator as well, they have been wedded to their calculators for 3 years, and now they have to put them down and take them away and try and do things without them, and they hate it. So that takes quite a lot of practice. Now, having said that it's mainly on the for A-level, so there shouldn't be huge amounts, do check carefully. Schools are now teaching the A-level syllabus sometimes in different orders. People aren't doing the AS exam at the end of year 12, so not everybody is following, not every school is following the AS content in year 12 and then the rest of it in year 13. So some schools are mixing it up, so do double check and make sure that all the content has been covered. Now, if you have a pupil doing international A-level, this is modular, so they have different papers that they do, and they can do different papers at different times. So it should be okay as long as they have doing them in a sensible order. So most of the content is in P1 and P2 with a few bits in P3 if somebody is doing the international A-level. But then again, the same things about the combinations and permutations, logic-based questions, and lack of calculator. So now just have a quick look at how this links with IB. So if you're doing the International Baccalaureate, the problem is with both versions, the AI and the AA versions of the International Baccalaureate, there is a much, much stronger reliance on graphical calculators in those than even the A-level does. So taking the calculator away and practicing is really, really important. The IB AA course is very similar to the A-level course, but the order in which the content is covered, if you look in an IB textbook, the order that it's done in is significantly different than the order that you would expect A-level to come in. So very much so an IB student needs to check to make sure, have they covered all the content, and make sure that they have enough time to actually learn any content that they don't already know. So a little bit more time come in. Somebody's doing the AI course, I'm afraid there are significant gaps in the content covered, which is probably why some of the other universities actually just don't accept that course. So if a pupil is studying the AI course, they probably need to be starting over the summer, sort of even now, to start to be looking at the content that they haven't covered in their course, so that they can learn the content, process the content, and then actually start working on the test. Okay, so that's content of it. Now, what are these aptitude tests actually like? So the MAT. So remember, this is the Oxford one that Oxford and Imperial say you have to do. So the MAT consists of 7 questions. Each applicant has to do 5 of them, but they're specified by the course, so they don't get to pick and choose. So they have to be able to do it all. It's 2.5 hours, so it's half an hour per question. However, the first question, question 1, is actually 10 separate multiple choice questions. So if you're going to spend half an hour on here, you really want to be trying to get each of these 10 multiple choice questions done in 3 minutes each. Okay, which is quite tight. It takes practice, and they need to start to learn tricks of how to speed up, what to spot in the questions. A high-performing candidate, when they start to practice these, are likely to be taking 30 minutes a question at the beginning of when they start practicing, and they've got to cut that back from 30 minutes down to 3. So it's quite a big set, and that's for somebody who's going to do well. Questions 2 to 7, so 4 of these each candidate does. These are longer multi-part questions. So you're taking half an hour to work your way through a question doing these. These require a high level of understanding, and they often require pupils to draw on little different bits of knowledge from different parts of maths. It won't be a question on a topic particularly. They've got around, depending on how long they've taken on question 1, they've got about 30 minutes for them, and that's okay-ish actually. But again, initially when they start practicing them, they can take days thinking about an individual question, that they will start to read and they'll think, I don't know how to approach this, what do I do? They might get through the first 2 or 3 parts and then get stuck on a part. I would thoroughly recommend not going and looking at mark schemes at this point. Do spend days on it, sleep on it, come back, have another go, think about it, because they're not standard questions that they can keep coming back to and go, oh yeah, it's one just like that one, I can do it again. That isn't what's going to happen. So what they need to be learning as they're practicing for this is the thought processes for problem solving. So going and just looking an answer up doesn't help with that. They have to actually work out how to work through that process. I will often, when I'm teaching pupils, talk about what's the hook? What tells us to do the thing that we need to do? And they need to learn to spot the hooks and think about processes and problem solving processes. And a lot of these pupils will have spent their entire mathematical lives just being able to read a question and go, I'm going to do it like that. And now suddenly they've got a question that they might have to think about for a day or 2, and it bothers them. So here's an example. So this is one of the multi-choice ones. So this is one of the 3-minute ones. It's a question B. And as a question B, that means that they do tend to get harder as they go through. So this is the second question. So this is fairly simple. So, and it says we've got the sum of 2 n terms of this sequence, and we want to just find out what it would add up to. Now, the problem that pupils will have is that they will have seen sequences before, but not one like that. And while it's multiple choice, we can't use the answer and put it in and work backwards to it, because as you can see, these are not those sorts of answers. So they have to be able to do it. So this is the hook you need. So when we look at this, I'm sure if I said to anybody looking at this, I'm sure you could say, well, if I said, what's the next one? And go, well, we're doubling that, so to be 32, and the next one's 1 over 32, then to be 64, 1 over 64. So you can see that. But the trouble is that that isn't a sequence that we can have a formula for that can do this. So what the pupils have to notice is that this isn't a sequence, it's two sequences. It's one that goes 1, 2, 4, 8, and 16. And it's another one that goes 1, a half, a quarter, an eighth, and a 16th. And so these are two separate sequences, but these are sequences that a student would recognise. And there is a formula for each of these for how you would then work it out. So they're both geometric. There's a standard formula for the sum to n of a geometric sequence, which goes like this. And we can look at this. A is the first sequence, so it's 1. R is what are we timesing by, so in this case it's 2. Here, this is 1, and R equals a half. So we can put these in, and so for the first one, I get 1 times 1 minus 2 to the n over minus 1, which is 2 to the n minus 1. And the second one is 1 minus a half to the n over 1 minus a half, which goes to 2 times 1 minus 2 to the minus n, 2 minus 2 to the 1 minus n. If I add these two together, I will get that. And that's a 3-minute question. So they have to look at that, spot that it's two separate sequences, realise that that's what's going on, and that's the hard bit. Then know this formula, which at A level they would be given. Use it, no calculators, do this little bit of maths, work it out. These are hard questions. This would be the second easiest question on the paper, though. So they aren't easy. Example of a long question. So don't worry, I'm not going to go through this one. As you can see, this is a long question. This is for everybody, but it just gives you a flavour of the sorts of things that we're talking about here. So the sort of things that we're talking about in terms of a long question. This question, it talks about, we've got children sat clockwise in a circle. We've got a teacher walking around with a ladder. She's giving sort of one child, then skips one. It's complicated. It's going around. And then we're starting to look at how this process works. And they've got to work their way through this question. So this is a long question. They'd have 30 minutes to do this. They will never, ever have seen a question like this before, and they will never see a question like this again. So this is, they have to, it's a very unfamiliar situation, and they have to work their way through it. Okay, so my mouse is stuck. Okay, so in summary for the MAT, sat in November, it's required by Oxford and Imperial, optional for Warwick, and that other group of universities, if you sit it, they will take it into account, and you can get a reduction on your A-level options, A-level requirements for that. It's based on A-level year 12 plus, so plus a few bits. Anybody doing IB or an international A-level student might need to learn some additional content, but it's all about the in-depth problem-solving skills, as well as mental maths and speed work. Okay, so if we move on to the CTMUA, so this is the Cambridge computer science one, but which is also accepted by Warwick and the other ones. So it's also 2.5 hours. It's split into two separate 75-minute papers. So you do the first one, timed for 75 minutes, and then they take that and then the next one. So you can't run over one time and grab time from the other paper. This time, both the papers are all multiple choice. They both have 20 questions on them. So you're at about the 3 to 4 minutes per question. But you don't have these longer problem-solving questions. Paper 1 is said to be mathematical thinking, and it's all about, again, applying maths in unfamiliar circumstance, but I don't think they're quite as tricky as the math questions generally. They're certainly not as tricky as the long questions in the math are. Paper 2 has some questions very similar to there's a big overlap between paper 1 and paper 2, but probably about half of the paper 2 questions are logic-based questions and error spotting type questions. So in particular, this paper requires a lot of practice to understand the style of the questions and start to see, again, what are the sort of things that they tend to do, what are you looking for. In it, they have some very specific language that's used, and you need to understand what that language is. So it's, if it might say, what is the negation of this statement? It might ask a question to say which of these things are necessary or necessary and sufficient, and pupils need to understand the difference between these. Overall, it's more of a speed test than the MAT, and again, it has no calculator allowed. So it can take, sometimes it can take more practice than the applicants think it does when they start to look at it, because they look and think, oh yeah, the questions are fine, I can do those, and then they find they can't. So here's an example of a paper 1 question. So it looks reasonably straightforward. We've got a summation of sine, so this will be going, start off with k equals 0, so I'll have sine 10, and then I'm going to have, when k equals 1, I'm going to have sine 100, and then if k equals 2, I get sine 190 plus sine 280 plus until I get up to the final. Until we get up to the final one, which and it is non-calculator, so I'm not going to even try to think to work out what number that would be. I know what it is, I say, yes, because I can do 90 times 90. But you wouldn't worry about that. So we've got this. We have got a clue here from what's going on, that this isn't just a straightforward summation, because we've got a clue, we've got some answers here, and we can have a look at it. And what people should know is that sine goes like this for infinity. And so sine of 10 is going to be about here, and sine of 100 is going to be about here. But then sine of 190 is going to be here, and sine of 280 is going to be here. And these two are going to be exactly the same value, except that that one's minus. So they're going to cancel each other out. And then that will cancel with that. So that's actually what this is about. So this is about pupils having to notice that this is what it is. And what this is actually saying is you need to look at the end of this and go, what's happening at the tail end of this? So I'm going to have the last little bit. Where does it go? Well, the last one here is sine of 10 plus 90 times 90 is there. This is sine of 10 plus 89 times 90. This one is sine of 10 plus 88 times 90. And so that one is going to cancel with that one. This one is going to be left. This is the same as sine 100. So the answer is C. So they've got 3 to 4 minutes to work that through. So it does take practice. Okay, so that's a paper 1 type question. This is a paper 2 type question. So this is a logic one. And so some of the logic ones are straightforward, what you would expect from logic questions. Some of them are a bit more like this. So we've got a circular table, has 40 chairs sat around it. What's the smallest number of people who can be sitting at the table already, so that the next person to sit down must sit next to someone? Now, if I was going to do this, first thing I would do is, right, here's my circular table. I've got somebody here. If I don't want somebody sat next to me, I must have seats on either side. If the next person to sit down doesn't have to be there, then I've got to have somebody here, because then the next person would have to sit either here or here. So suddenly, as soon as you start to think about it like that, you go, oh, okay, I'm going around in threes. So if I've got, here I've got 12, I need 4 people. But if I put an extra one on here, so I've now got 13, I'm going to need an extra person. So 1 more seat gives me 1 more person. So now the question is, what happens when I divide 40 by 3? Well, I get 13, remainder 1. So I'm going to need 14. And it's that level of working it through. So I did a classic problem solving technique there of simplified it. I made it smaller. I didn't start to try to put 40 round, and I tried to see what so I did 2 things. I simplified it and I spotted a pattern. And then the next trick you have to have is to then clear your mind and move on fast, because you've not got much time before the next one happens. So TMUA is also sat in November, like the MAT is. The CTMUA, which is the same test required by Cambridge Computer Science. TMUA is one of the Warwick options, and the other universities will take into account. Again, A-level year 12 plus, but this particularly mental maths and speed are key, and you need the logic specific language understood. And these type of questions need practice. Okay, so the CSAT, I mentioned when I put that this is a little bit of a sort of dark world, this. The CSAT is required by some Cambridge colleges for applicants to computer science. It is sat in November, but is after the CTMUA, and it is by request from a college. So if somebody's done well in the CTMUA, and it's one of the colleges that likes to see the CSAT, they might then get a request to go and do this as an additional test. It doesn't mean they've done badly, it means they've done well. So it means that they are being seriously considered. And so it isn't one that's advertised. Quite a lot of people might not have even heard of it. It is quite different from this. In fact, I would say it's almost the exact opposite. You can choose your questions you want to do in it. The questions are, they contains questions on a variety of different topics. It rewards only the best solutions that people do. So if they start something and it goes wrong, then that's fine. They, well, it's better if it goes well. But if you do things in 2 or 3 different ways, they will look at them all. They are looking for how somebody's brain works, not whether or not they can do quick mental maths. They will ignore a silly mistake or even a wrong answer if the thought process is good. They will actually they are looking at the content when they look at this, not a score. So you could have 2 candidates that got the same score, and one of them will have passed with flying colours and the other one will be rejected at this point. You could even have one where somebody with a higher score was rejected because they're looking at the thought processes and the way somebody's brain works rather than straight test. It lasts for 3 hours and the candidate's best 6 answers from 13 questions are taken into account. It's my favourite of the tests because I think that it does test the right thing. It's looking at how somebody thinks and not saying, oh, under pressure they said 2 + 2 was 5. That's fine. There isn't any new knowledge required for this. Saying you don't get warning about it. If you are applying for computer science, I would definitely look up CSAT though, just in case. So this is an example of a type of question that you might get on there. So a 3-digit lock. It gives feedback whenever it's tried. What is the correct unlocking? And here is some feedback. To me, this is a little bit like I used to play a game called Mastermind when I was younger, where you had to work out what the different coloured things were, and you'd put little black and white pegs in to say how many of them were right or wrong. Is that same sort of idea here, but it's working through the process of this. And so you can see it's very logic based. Not all of them are as logic based as this in the CSAT. There's some quite pure maths questions that are asked as well. But I do like that test. It's a little bit of an unknown one that people, but it's well worth looking up if you've got somebody going for computer science. Okay. Then 6-term extension papers. These are the STEP papers, which are I would expect most maths pupils would have heard of these. They're required by all of the Cambridge colleges for any maths course. Some of the Imperial Computer Science course also put them on, and it's also recommended by a lot of universities to do it. And I think it's expected for people who are really passionate about maths to want to do it. I did it when I got into Oxford having done the entrance exam. And so and in those days, if you passed on the entrance exam, you only needed 2 A levels. So I needed 2 E's as my offer to go into Oxford, but I did the STEP papers. And I can remember the very first tutorial that I had at my college. They had the 8 of us from my college doing maths all sat together, and one of the tutors said, "Oh, you 6, yes, you did very well on the STEP. Yes, very pleased with that. You 2 who didn't do the STEP, so why didn't you do it then?" And they both said, well, we didn't know we had to do it. And they sort of said, "But aren't you interested in maths? I thought this was meant to be your subject. Wouldn't you want to do it?" And so there is that sort of expectation of pupils to want to do it because it's high-level maths. Unlike the other tests, this one is taken in June at the same time as the A-level. And if it's compulsory, there will be grade expectations set as part of an offer. There are now only 2 of the STEP papers that are offered, so Step 2 and Step 3. And a Cambridge offer will usually include grades required for both of those 2. Step 1's now been discontinued. They didn't decide to just start counting at number 2. But if you've got somebody who, if they're not doing STEP, if they're just wanting to get a high grade in maths, STEP papers, Step 1 papers are a good place to go to look for hard questions to practice. For Step 2 and Step 3, each of them consists of 12 questions, 8 pure, 2 mechanics and 2 stats. And it's just like the CSAT, it's assessed on answers to at most 6 questions. So if somebody attempted to, you wouldn't, but if somebody attempted all 12 questions, they would only get marked on 6 of them. There are 5 grades from highest to lowest. So an S is exceptional, a 1, 2, 3, and a U is ungraded. In terms of the content, the STEP syllabus is based on A-level maths and further maths. So Step 2 is A-level maths and AS, so the first year of further maths, or the equivalent of that. Step 3 is based on a typical further maths A-level syllabus, so all of single maths and all of further maths. And they're intended to have a difficulty of questions about the same as Step 2, it's just that the content has gone up. So whilst you're only doing 6 out of 12 questions, this is mainly because the test covers the whole of the further maths syllabus except for decision, which is the sort of computer science sort of little bit of further maths. So while you've got the choice of all the questions, the chances are most pupils aren't actually going to have studied the content of all of them. So because students only study 4 out of 8 options, roughly, depending on which exam board they're on, but that's generally about how it works. So most pupils are not going to have all 12 that they can pick from. So they might want to then do some additional work outside of what they're actually needing to do for their own further maths A-level or their IB, in order to just extend the range of the questions. And actually, to be honest, if you're going to go and do a maths or computer science degree in the future, why wouldn't you want to study some of the bits of maths that you haven't studied as part of your A-levels? It would, it's going to set you up well for your degree anyway, so it's worth doing. For those studying international A-level, it's not hugely dissimilar because it's taken it in June. Everybody's done their whole courses again. There are some bits that aren't covered in international A-levels, so some favourite topics, so permutations, combinations, reduction formulae, some of the matrix algebra. These are really common topics in STEP, so they're well worth making sure they've got them. For the IB, so as I've said before, Cambridge and Warwick will not accept the AI one, so I'm only going to look at the AA International Baccalaureate course. In that course, there's no mechanics covered at all, and the statistics is covered in that course. This is in the AA course, so this is the one that's more closely linked to A level. But the statistics that's covered within there doesn't extend very much beyond what you would just do in single maths. So this means that an IB pupil, if they don't study outside of that work, they're going to be unlikely to attempt anything more than the pure questions. And even within that, they're likely to have restricted their choice of questions. So I would say that anybody studying IB, they're going to really need to try and study some additional content as well as the different style of questions. They're going to have to put some effort in to learn some things outside of their International Baccalaureate course, because otherwise they're going to struggle. So a few topics that come up commonly. I have got a full mapping of how the syllabus, how these syllabus link up. Just, you know, I don't want to go through every single line of it, but if anybody wants a copy of that so they can see exactly what's needed, then please do just ask. So what is this STEP Maths thing? So all of the questions on it are long. They're all about 30 minutes per question. They're usually multi-part. They have their own, very much their own style. I've been shown questions when somebody said, oh, can you help with that? And I've almost sort of barely started looking at it, and I've said, oh, that's a STEP question, isn't it? So they do have their own style, so you do have to practice them to get to know how they work. So you do need to complete lots and lots of questions before the exams. You're going to need your full problem-solving armory to answer these. These are hard. So to give you an idea, the grade boundaries in 2019 for the exceptional, so the highest level, we're looking at 75% in step 2, 64% in step 3. Cambridge need a minimum of a grade 1 in both as part of their offer. Warwick, not quite so much. They want a grade 2 in either one of these two. But as you can see, if you've got the people who are doing these tend to be the best people in the country at maths, and they are getting these sorts of marks. I was doing some STEP questions with a pupil of mine he's hopefully, as long as he gets his A levels, which he should do, he's going off to University of Durham to study engineering next year. And we got partway through a question and he just stopped and he says, does anybody actually manage to complete any of these questions? They're hard. So these are the results from step 2 and step 3. So I've put the red line down there. That's at half marks. It's out of 120. So you can see considerably more people get less than half, and there are more people down at the below 10 than you've got above here. So they're tough questions. So give you an idea, I'm not going to work through these because say they're good half-hour questions each. So this is a half-hour question, which is scary just of thinking that that's half an hour's worth, because you look at it and think, but it's only a couple of lines. So there's an awful lot of work in here. What's very STEP about why I picked this question in particular is you've got part 1 and part 2. On the face of it, you can see that there must be links, and it says hence. So that must be, these must be linked together. Actually, without doing part 1, part 2 would be almost impossible. And there's a direct link between part 1 and part 2 in here that then makes part 2 doable. So the pattern of how this has been done is then the pattern that you end up having to use in part 2, but the question doesn't say that. And that's a very STEP thing to do. So as you can see, very mathsy, very pure maths, and say their own particular style. Now the next one, I think this is one of my all-time favorite questions. This is a probability question. Very wordy, a lot of the probability and the statistics questions and the mechanics question, very wordy, lots of stories. I love this. Mr. Blonde returns to his flat. I think that there's a Reservoir Dogs fan who's written this, and we have got a deadly trained silent anaconda and a vicious attack canary going on in this question. So the people who write them, they do have a sense of humour, but there's a lot of content in here, and again, just as I was saying with the MAT questions, they'll never have seen a question like this before, and they'll never see one quite like it again. So they do take a bit of working through. So this step is required for Cambridge Maths. It's one of the ones that Warwick will accept. Imperial will accept it if people miss the deadline for the MAT or the TMUA, so they can use step instead. Only step 2 and 3 are now running, and it's based on the A-level maths and further maths and taken in June at the same time as those. Very high level of problem solving skills. Many of the pupils would benefit from extending a knowledge base beyond what they've actually been taught as part of their normal courses. Okay, so overall for the maths and computer science, we've got Oxford and Imperial require the MAT, SAT in November, problem solving, pretty hard. Cambridge Computer Science needs the CTMUA, and the TMUA, which is the same test, also SAT in November. It's not so much problem solving, but more logic and more time pressured. And then Cambridge Maths, and basically, as I said, any budding mathematician should be looking at step 2, step 3, SAT in June, very, very challenging problem solving. But international A-level and IB candidates, check your course carefully, make sure that you know sufficient content well in advance. Okay, so that's all of the maths and computer science. So looking at the physics and engineering. So again, let's start just by looking at the A-levels and IB requirements. So general knowledge about what's here. So the A-levels, unsurprisingly, you should be doing physics, you should be doing maths. Further maths isn't compulsory, but it is a very good third option and is recommended by a lot of the courses. Some, if you were doing chemistry instead, then that's fine. Other ones would be fine. Some there are some courses where they won't accept some A-levels, so do check individual courses. But further maths is a good third option. If you're not doing it, then actually just doing some of the engineering physics bits of further maths is a good idea. IB maths, again, you would expect physics and maths at the higher level, and we've got the same problem again, that universities will only accept the AA course, not the AI course for this. So the additional tests for physics and engineering, these are not as widespread in engineering and physics as they are in the maths and computer science. So there's the Oxford Physics and Engineering and Material Science courses. They have a test called the Physics Aptitude Test, which is called the PAT. And Cambridge Physics and Engineering, if you're doing physics, you would do the NSAA. And if you're doing engineering, you would do the ENGAA. So let's have a look at the PAT to start with. So required by Oxford, taken in November before the admission the following September. Now, as far as I'm aware, other universities don't look at the results of this, but I'm more than willing to be found wrong in that. I've not heard of that happening, but it might. It consists of 1 2-hour written exam. 24 questions on the paper, all of which have got to be attempted, so you can't decide what you want to do. So they've got to have covered it all. Again, the marks are like this, they are low again. So 49% was the mean, 67% was an automatic shortlisting for 2020. So they are hard again. It's based around A-level physics and A-level maths. So it's a maths and physics test together. Again, SAT in November. And again, it is restricted to what you would expect to do in your first year of physics and maths A-level. Now, here's one of the things. You are allowed a calculator in this, but no formula books. But your standard A-level maths calculator is not allowed. So the standard A-level maths calculation that they will all have now does some differentiation and integration, and it has quadratic solvers and things like this. These are not allowed in the PAT, so you'll have to go and dig out their old GCSE one and get used to having to solve quadratics for themselves again. Looking at the IB, as long as they're doing maths and physics at a higher level, and preferably the AA course in maths, most of the syllabus is covered by this, but there are some optional parts of the physics IB course where it's optional on the physics one, but it is on the PAT syllabus, so people would need to double check. And you've got the same problem again with the order of them being studied to make sure that you have done the right things by November. And you've got even more so that in IB maths, they use this graphical calculator, which just is not allowed. So they will have to make sure that they have a calculator they can use and know how to use it and know how to do the things that they're used to having a calculator do for them. So as I said, currently there are 24 questions. They have been mixing it around a bit the last few years. So if you look at past papers and go, oh, but why is that like, that isn't like what we thought it was going to be? Yes, they've changed it fairly, they keep changing it around, they can't make their mind up with it. But at the moment, we've got 24 questions, first 12 are multiple choice, and they've mixed the maths and physics up together, so there's not a maths section and a physics section. There's 100 marks altogether in 2 hours, so if you work on a mark a minute, you'll have 20 minutes to overrun on. So that's pretty good. Compared to the maths questions are fairly straightforward, but there's a physics problem solving in them. It is quite time pressured. It's quite easy to get lost down rabbit holes of, you know, doing questions and then suddenly realize that you've spent 10 minutes instead of 2 or 3. So this is a 2 minute, or this is a 2 mark question. So you'd be looking at about 2 minutes. And it starts off most year 13, November year 13, students would look at that and go, oh, okay, right, yes, that's that. I know what this is, but it does say without explicit calculation, state which of these are non-zero. So you just want to know which ones aren't zero. And a lot of students, I think, would be very tempted to start to try to calculate, and they just, they haven't got the time. That one, they can't do it. You'd need second year uni maths to be able to solve that one. So they just can't do that. So they have to think in a different way. And this actually, it's not an integration question. It's actually an odd and even functions question. So this is saying, is this a function which rotates around here, or is it a function which reflects around here? They're even, they're odd. X squared is even, sine is odd, therefore together that makes odd. This one's even, this one's even, this one is odd. And so if you reflect around here and you're going from minus infinity to plus infinity, it will add together to make 0. If it is even around here, it will add together to make that. So the answer is that. But it's the fact that that isn't about, it isn't about integration, that is about graphs, and that makes that hard. Okay, so that's an example. So that was a 2 minute question. This is a physics question. And this is a good example of one that I can think of where it's, I said you can disappear down a rabbit hole if you're not careful and just take too long over things. So this is a very straightforward physics question. It's basically saying, here we've got a light bulb. If I close these, if I have none of them closed, it won't come on. But if I have just A closed or just B closed or both closed, which of them is going to make the light bulb go the brightest, the middle, the end? And so what they are needing to do is to go, okay, how the brightness is proportional to V squared over R. We're told that V is constant, so we're just looking at 1 over R. And then we're just saying, okay, if I close A, then the resistance I'm going to get is going to be 3 over 2R. B only resistance is going to be 2R. That's nice and easy. Both. And this is, so you're going, okay, so the 1 over the resistance is going to be 1/2 plus 2/3 of R. So that's, and now you're doing it without a calculator, or you have got a calculator for this at least. So this is going to give me 7 over 6R. And so that's going to give me that RT is 6/7. And then you've got to think, okay, so now what does it mean? So the resistance, 1 over the resistance means that it's inversely proportional. So it's going to go B, A, both, and it's C. And that's a 2-minute question. So it's very easy for somebody to get lost in doing calculations and to spend just too long on them. So that's part of the game with this. This is just this is one of the longer ones. So this is a 6-mark question. And it's just a straightforward graph sketching. It is for somebody who's doing A-level maths, that's straightforward. The thing that I think they'd probably forget is describe 2 features, and this last one here, they're going to infinity, but it's fairly straightforward. It's quite a nice question. So in summary, the PAT is required by Oxford, physics, engineering, etc. It's a mixture of maths and physics. Problem solving ones included. Keep an eye on the clock, but work carefully. What is quite nice, which I didn't mention, in the multiple choice, they do look at your working. So if you get the answer wrong, but you've got your working right, you can still get 1 out of 2 of the marks, which is quite nice. Okay. The NSAA and the ENGAA. So these are the Cambridge tests. So natural science applicants to Cambridge includes a compulsory maths section, and you've then got a choice of physics, chemistry, or biology. So if you're looking to do a physics degree, you'll be asked to do the NSAA, and then you would choose the physics option. If you're doing engineering at Cambridge, then you would do the ENGAA, and actually it is the same test. So the ENGAA and the NSAA physics part are actually the identical tests. So if you're not sure which you're thinking of doing, that's fine, because they're actually exactly the same test. So the test, it lasts for 2 hours. It's split into 2 sections, which are individually timed at an hour. So again, you have an hour, do the first one, hand it in, next one. Section 1 has got 40 multiple choice questions. So you have got 40 questions in 60 minutes. So you have less than 2 minutes. You have got 1.5 minutes a question. Section 2 is also multiple choice with just physics questions with 20 questions. It is all non-calculator and no form. So you're not even allowed the sort of GCSE calculator, no calculator at all. The content actually is fine. It's top end GCSE. And this is actually where the difficulty arises, because it's not about the content, it's about how fast you have to work. A lot of pupils will they'll go, oh, I've got to do this test for this. Look and go, oh, that's dead easy. Oh, I'll be fine. And then they don't look at it again. And then they go and do the test, and they've barely got halfway through it, and the time's up. And then it's all gone wrong. So it's the speed that you have to work. Unlike the PAT, where they do give marks for working even on the multiple choice, they don't. You either get the answer right or wrong. So there's no working marks given. And there are more than 4 options given. You can have 8, 9 different options. So it's not like you've got 25% chance of guessing. No calculator. there aren't the same problem solving elements as in the MAT and the PAT, but it's the sheer speed, which means that candidates, they're just going to have to be instinctive and work through them. So let's have a little look and see what happens when you try and do these. So this is a 90-second question. So I shall work through it. So it's not hard, it's GCSE maths. So we've got, first of all, what have we got going on? Similar triangles, AB, that's 4. BC is x, DE x plus 3, DB x minus 4. So AD, we add those two together, I get x. I'm trying to find DE, so I'm going to get, look at the ratios, so 4 over x, so that over the whole thing is the same as this over this one. So I've got my formula set up, so I've now just got an equation to solve, and now I've got a quadratic. I have no calculator I can use. I've got to remember how to do this without using a calculator, so I'm going to have to factorize this. I get that, so x is 6 or minus 2, that's clearly nonsense. X is 6, so x plus 3 is 9. I obviously knew the question, I knew what I was doing. I'm quite good at these if I say so myself. I've done a few of them. And that probably still took me more than a minute and a half. You have to work at speed. So that's question here, physics question. So again, a minute and a half. This is a straightforward SUVAT question, but we've got to read it, right? We've got U equals 12, kinetic energy, what the height? So we're going to have A equals minus 10. We've got, we're going up to the top. So V is 0. The thing we're trying to find is that. We've got to remember that V squared equals U squared plus 2AS. These are now given in A-level maths, but you have to memorize them and know them for this. And so we've got to put this lot straight in. And so we've then got to do 144 divided by 20 in our heads and get 7.2. And that's our minute and a half. So it's the time. See, that's the problem, is a student would look at this and go, oh, that's a really easy question. That's easier than A-level. But they're not used to doing it. Right, a longer question. This time, this is a 3-minute question. And I've picked out this one in particular because I think it's a really nice example of the difference between A-level, doing A-level or IB and doing this test. So, as you can see, a very long question. It says the pressure is exerted by a gas at a constant temperature is directly proportional to its density. Spherical bubble of gas forms at the bottom of a glass containing a fizzy drink. Radius at the point of formation at the bottom is big R. Depth is H, density is rho, atmospheric pressure is capital P. As the bubble rises, its radius changes. Which expression gives the radius at a distance x below the surface of the drink? Okay, so although it's a long question, it is fairly straightforward. It's, you know, at A-level you'd think, yay, great. And if we're going to do this at A-level, we'd go, okay, so here's our thing. So here's our bubble. We've got H here. We've got a radius of R. So idea of what's going on. The thing to remember is that PV, so the overall pressure times the volume is going to be constant. So the hydrostatic pressure at any point is going to be rho G times whatever the depth is. So we're going to get rho Gx plus P for the atmospheric pressure. And so then we're going to get 4 pi over 3 times little r cubed is going to be rho GH plus P times 4 pi over 3 times r cubed. Okay, so these can cancel out, that's all right. And so if I move that over there, I get r cubed is this over rho gx plus p, and then I've got r cubed there. So I then need to cube root it. So I'm going to get r is going to be the cube root to the third of r, which is that. And that's fine, and you'd write that down. That's certainly taken me longer than 3 minutes. Even reading it and working out what's going to get on. But that's what you'd be expected to do for an A-level question. So how can we go about doing this in 3 minutes? Because you just haven't got the time to do this. So how can we do it in this time? So what would actually be expected to happen is this. So instead of working through it like that, it would be more a case of them going, okay, so PV is a constant. We can see straight away that the overall pressure is P plus rho xg. So look at the answers. Okay, right, so I can get rid of that one, I can get rid of that one, I can get rid of that one, I can get rid of that one. Because I've got rho plus and they've got these got minus or not at all. So it's got to be C or F. So looking at C or F, now stop and think about it. As this goes up, the radius is going to get bigger as x gets smaller. So the difference between these two, one of them I've got x on the bottom, one I've got x on the top. That will get smaller as x gets bigger. That will get bigger as x gets smaller. So therefore the answer is that one. And it's that sort of instinctive working through that is actually required, because you can't do this question in the time they've got as you would expect it in an A level with all the working nicely shown. You've got to do, right, it's not that, it's not that, it's not that, it's got to be that or that, which one's it going to be? And that's how they've got to work through, which is a very different way of working, and they just won't be used to it. So the ENGAA and NSAA, they're required for physics and engineering. The content is not very challenging, but the time restrictions makes it very, very difficult. I call it the "Are you feeling lucky" test. However, as Gary Player, golfer, once said, the more you practice, the luckier you get. So you do have to practice. You have to practice the mental maths needed. You have to practice those sorts of shortcuts. Can you just see it? Can you work out, oh, it's got to be that one, because that's logically how that works. Right, next question. So the more you practice, so many pupils look at this test, have a quick glance through, go, oh, dead easy. I don't need to do that, and then trip up. They need to practice it. So do not underestimate and therefore under-prepare for this test. Okay, so physics and engineering, the PAT from Oxford, sat in November, problem solving, a little bit time pressured. But the Cambridge one also sat in November, time pressure off the scale. It's madness on that one. So I hope I haven't kept you all for too long. That's everything. Thank you so much again to Saba for organising this, and the Oxbridge and University Facebook group for allowing me to use this. Thank you to anybody watching live, and anybody's come back and watch it. Anybody that's just got any questions at all, wants any more information or detailed content, do just get back to me and ask questions. I'm more than happy to help people through this. I had people who helped me many years ago for me to get through to Oxford, and I'm always very willing and to talk to people and help people who want to try it for themselves. So good night everybody, and thank you very much for your time. Take care.